Welcome everybody to today's FDTD GOES 16 Applications webinar. Today we're pleased to have Todd Lindley from the WFO in Norman, Oklahoma to join us, and the title of his talk is Wildland Fire Notifications for Impact-Based Decision Support Services in Oklahoma. Next slide, Todd. Before we begin, just to go over some protocol, all of these are recorded and made available on the visit web pages at the URL indicated on this slide. We'll have Q&A also at the end. And we have a call for speakers. If you're interested in leading one of these webinars in the future, please let us know, either myself, Dan Bicus, or Scott Lindstrom. Next slide. And just some protocol to go over. We'll have about 20 minutes for our speaker, and you can either send questions via the GoTo chat, or once he's done speaking, we'll have a Q&A period over the phone. We'll be done by 18:30 UTC, and please remember, do not press hold, and also to remember to mute when you're not speaking. So at this point, I'll turn it over to Todd.
Hello, thanks. Today I'm going to talk about the use of wildland fire notifications for impact-based decision support services here in Oklahoma, and we're going to even speculate a little bit how this might be a prototype for future National Weather Service red flag warning paradigms. Again, my name is Todd Lindley. I'm the Science and Operations Officer here at WFO Norman, and I also have in here Aaron Anderson, our ITO, who is actually the guy that made all of this happen, and we'll talk about that story in the background about how we started issuing these wildfire notifications or hotspot notifications for wildfire here in Oklahoma. So, of course, I think everybody on the call will be very well familiar about satellite and remote sensing capability for wildland fire and the background of that use. But what I really want to say here is, acknowledge that we are in a high-resolution era, if you will, for remote sensing of wildland fire, and of course, other hazardous phenomena as well. And of course, largely that's being driven by GOES 16. GOES 16 really is a game changer for the National Weather Service and the way we conduct fire weather operations. It has been here in the Southern Great Plains, and I'm sure it will be across the country as well. But let's not also neglect the existing Doppler radar network as well. We're learning that we're just really seeing the very tip of the iceberg as far as innovations that can be made in tactical fire support, even using the 88D network, and especially now with SAILS and dual pole, things that we're starting to identify fire mode, analogous to convective mode, for debris plumes seen on radar, watching fires interact with horizontal convective rolls, and these sorts of things have potential for tremendous tactical value on the ground for firefighters. So the story of how WFO Norman began issuing hotspot notifications for fire in Oklahoma began before GOES 16 was even placed into orbit. It began back in February of 2016 when GOES 14 was operating in SR-SOR, which of course was Super Rapid Scan for GOES-R operations. It was basically the predecessor allowing developers to develop the algorithms and such needed to operate GOES 16. So they would use GOES 14 in a 1-minute temporal scanning strategy. And in February 2016, we were expecting a pretty high-end fire event across Oklahoma. SPC had an extremely critical area out. It was a day we had 72 major fires erupt across Oklahoma, burning about 130,000 acres and losing more than 600 structures across the state. So going into this highly anticipated fire event, the Oklahoma Forestry Service's Fire Management Chief, Mark Goller, gave our office a call and asked if we would be kind enough to give him a call when we detect newly igniting wildfires on satellite. Of course, they wanted to be very proactive and attack those early and fast. So that just so happened to be one of the experimental days for SR-SOR, which was operating in support of Vortex Southeast. But we had a GOES 16 liaison over at the Storm Prediction Center, Bill Line, who came over to the WFO and mentioned that they were moving the SR-SOR domain over the Southern Plains in support of fire operations. So our response was to Mark Goller was that we can probably do better than just give you a call. We might be able to have a notification system set up. And of course, the bottom line in the office was that this was a day we needed to innovate. And Aaron Anderson, our ITO, was out in the operations area as the fire event unfolded. And by 1 or 2 o'clock that afternoon, he had a prototype system in place, and we were sending text messages directly to our fire partners, letting them know immediately when we were detecting new fire in the state of Oklahoma. So just to give you an idea of how it panned out that day and the advantages that we saw with the increased temporal resolution, this is the Buffalo Fire in northwest Oklahoma that started on February 18, 2016. And you can see the difference here between GOES 14, which was operating an SR-SOR with 1-minute updates, versus GOES 15 on the left in legacy 15-minute mode, and then GOES 13, which we had requested rapid scan operations for, so we were getting 5-minute updates. Of course, the real takeaway from this slide is not just the increased temporal resolution, but actually the time in which these images were viewable in our operational AWIP systems at the WFO. So for the GOES 14 SR-SOR, we saw that at the first initial signal of fire at 2049, and with the UTC, and with the GOES 13 operating in rapid scan operations, it came in about 8 minutes later. And then with the legacy GOES 15, it was not visible in AWIPs for another 23 minutes. So when you're talking about a fire that burned about 50,000 acres in a matter of 3 hours, minutes matter. So to the first responders. So we knew right then that, just with the increased temporal resolution alone that was coming with GOES-R, that we had the potential to make a huge impact on initial attack and mitigation efforts on the ground with these wildland fires here on the plains. Since Aaron first developed the application on the day of February 18th, it's gone through a number of versions, and this is the most recent version that you can see in AWIPs. And I want to point out that this is still operating based on a forecaster manually identifying a hotspot in shortwave IR, maybe fire temperature, RGB, any of the other GOES 16 fire products. But a forecaster does manually identify that. And we've had discussions about couldn't this be automated with some of the fire detection algorithms, and sure, it could, I think, as a safety net, but that would be very analogous to having, the radar algorithms issue tornado warnings based on TVSs. It would be a good safety net, but you may not want to rely on that. And in case, I'll show some examples of some very subtle signatures that we've been able to issue notifications for where the current fire detection algorithms did not trip. But just to give you an idea, a forecaster manually uses the point tool in AWIPs to highlight the location of the perceived hotspot in GOES 16 or other satellite imagery. And by the way, it can also be used for debris plumes indicated on radar as well. Anything you want to call out a very specific geolocation for. And then we indicate the fire weather level, which here on the plains is indicated by the red flag threat index. It's a quartile ranking, if you will, of RH and wind combinations. We also provide information about the detection method, whether it was in 1 minute, 5 minute satellite imagery, or maybe a combination of satellite and radar. It also appends a proximity observation from the Oklahoma Mesonet or the nearest ASOS, AWOS. A Google map a pin is dropped on a Google map, and that's provided. And then also the NDFD forecast weather planner for the fire weather parameters. And all of that is immediately transmitted via text message. You see an example of that there on the lower right. And also there are some processes that run by some of our users, including at the state capitol in the Emergency Operations Center, that allows for layering onto their GIS display on the watch duty officer map at the upper right. What has been some of the responses that we had? Well, immediately in 2016, when we started using it in the months of February, March, and April, it was determined by the State Emergency Operations Center that about 78% of the notifications that we transmitted that year were received prior to local 911 calls. So that was an immediate benefit, especially on the plains where you have very fast evolving fire scenarios. During 2017, across the state of Oklahoma, 236 notifications were transmitted, And the responses, mostly from Oklahoma State Forestry here, were very positive. It enabled rapid response that aided to reduce the threat to life and property. The timeliness and location of detected fires prompted prioritization of aerial and heavy equipment, and of course, probably the biggest impact of all, permitted contact with departments in advance of local 911 calls at the local jurisdiction. So of course there are a number of limitations, generally from this graph you see from Weaver et al. 2004, as fire temperature, burning temperature increases, the size of a fire that you need to actually be detectable via satellite decreases. So we have noticed a lot of variability based on the environment, exactly what kind of fire we can detect. But some of them have been very surprising, including the example at the bottom left, where we sent a hotspot on February 8th of 2017 for a fire in a rural area of Logan County, Oklahoma, which is north of the Oklahoma City metro area. Response from forestry that Logan County fire departments had been notified, and they were sending units to check it out. They get out there and confirm that it's actually a large structure fire, and you can see the response of this is really cool. So that scenario has actually played itself out probably 4 or 5 times here just in the WFO Norman CWA alone over the last year or so, where we've been detecting structure fires and providing notification for them prior to 911 calls, mainly, of course, in rural areas where folks are not, available to, they're not at home or not available to see those fires. Also, very intense burning on a very small scale can show up, as we've seen with oil rigs that are burning off excess methane in northwestern Oklahoma. Of course, the oil and gas industry is pretty big here. Remember, those are basically point sources, but they're burning at about 1,200 K or so. So very intense, and we see flares basically in the GOES 16 data associated with those. What is our precision as far as spatially? The early feedback we were getting, in 2016, 2017 indicated that we were generally about within 2 miles of a fire as far as our precision in placing that point, which is pretty good on the plains, definitely close enough to get fire departments in the right direction, notified and headed in the right direction, and they can see the smoke. Some of the feedback we received recently, though, has been that precision is actually increasing quite a bit. Now, this does induce a little bit of an operational workload. We basically have transitioned fire operations here in Norman to make them analogous to severe weather staffing levels. We have basically 2 quote-unquote warning forecasters that are interrogating satellite data and radar data and issuing notifications for hotspots that emerge. You also have to make sure that your NDFD forecast grids are very precise, because you're providing emergency managers with weather support before they even know they have an incident in many cases. So you want to make sure that information that you're sending them immediately is as precise as possible. So as always, we have someone on Weather Watch that's keeping those grids very precise. We try to minimize the workload by only issuing them in elevated or greater fire weather environments. So we're not issuing for every hotspot that we detect, and we're not continuously monitoring around the clock. We're only doing this in periods of elevated or greater fire weather, which would include all, red flag days, but many days in addition to that as well. Of course, we're not sending them for known prescribed burns, although I will say there have been times that we have noted substantial changes in the character of a prescribed burn, and we have sent notifications for those, and that has been of interest to some of our local users. There are a couple of cases where prescribed fire is starting to escape control, and we happen to hit that with a notification, and also even a few instances where ranchers were told by local authorities not to burn on a given day, and they did, and we were able to see that and get fire crews headed in that direction along with law enforcement officials, of course. But all of those are, we send the notifications straight to state forestry and OEM, so we're not disseminating them straight to the local authorities. We're going through that state filter and letting them decide how that information goes down to the local jurisdiction. Some of the most recent feedback we've received has been pretty stunning. Zach Stanford with the Oklahoma Department of Emergency Management says that he has no doubt that the program has saved thousands of acres, property, homes, livestock, and very likely human lives. that's been a great connecting force among the EM and fire communities across the state. Out in West Texas, Randall County Fire Chief James Amerson, who I've worked with for many years out in West Texas on fire-related issues, he says that the hotspot notification is one of the 5 greatest developments in his career, right up there with the jaws of life. And I know Chief Amerson's been on the job there about 31 years or so. At the bottom right, you actually see Texas A&M Forest Service Brad Smith, fire analyst Brad Smith, and he was deployed to WFO Amarillo, where they were using the hotspot in a training exercise. And it was very interesting to see how a fire behavior analyst would utilize this information in an exercise realm, looking at GOES 16 imagery, comparing that directly to Google Earth imagery, and being able to direct where evacuations needed to be targeted. During the course of this past fire season here in Oklahoma, we had quite a bit of fire activity. One of the notifications sent by WFO Tulsa was directly credited for saving the life of an elderly woman that was immobile. She was in her home. No 911 calls were received, but a fire notification was issued by Tulsa. Fire crews arrived just in time to save the structure and save the woman's life. It was immediately being threatened by the fire when they arrived. Also in eastern Oklahoma and WFO Tulsa's area, they were actually able to provide the initial notification to emergency services upon an oil rig that exploded near the town of Quinton, and unfortunately we lost 5 oil field workers in that explosion. But the notification provided via GOES 16 and the hotspot notification app was the initial notification of that incident as well. Down at the bottom, you see a timeline of response for a fire near Shawnee, Oklahoma, back in mid-March. It was initially detected with a notification sent by our office at 13:22. The Shawnee Fire Department received a 911 call 6 minutes later. And within 10 minutes of our notification, Oklahoma Forestry was dispatched and air tankers were ordered, and they were able to attack that fire with aerial support within an hour's time, as you can see there, and saved a plastics plant facility there near Shawnee. I want to point out some of the tactical decision support that we provided for the Ray fire, which was a mega fire in northwest Oklahoma between the 12th and 18th of April. Of course, all of this is based on imagery from GOES 16, but we sent a total of 20 notifications during the life of the Ray fire. Basically, this is a fire that burned an area larger than the Oklahoma City metro area combined. So this is a very large fire, burning about 288,000 acres or so. Pretty much the biggest part of Dewey County, Oklahoma, has been burned by this fire. And we were able to provide support by every time there was a change, an increase in the active burning in one area of the fire or the other, we're able to direct resources towards that. We had a Type 1 incident management team that was on site for this fire after the first few days, and it was the feedback was that it was incredibly useful for them to know where the fire was starting to flare up again on subsequent days. We've had requests to access the app that Aaron built and designed, and it is hosted on the VLab. Currently, I believe about 31 or 32 offices around the country have requested access to that app. We can't really speak to specifically which WFOs are using it operationally. We know that some are, for instance, here in the Southern Plains, Wichita, Tulsa, Norman, Amarillo, Lubbock, Midland. But we also know that some other offices have accessed it and they're looking at it and they're debating the pros and cons and the workload issues before fully implementing it in operations. So that moves us forward to, how could this someday provide a prototype for future NWS fire warning programs? And, basically, there's been a need recognized to move from more of what has traditionally been a strategic program geared towards providing strategic decision support for pre-deployment of resources before a fire event to more of a tactical type response, and this was well covered by Larry Van Bussum up at the 12th AMS Fire meteorology symposium in Boise last week. He presented on the future of red flag warnings and how the National Weather Service may begin to transition that program. So the real power in what we've been doing here with these notifications in the Southern Plains has been when we marry it with the more strategic approach of providing guidance on pre-deployment of resources to areas of heightened risk for significant fire. In this example, taking the deterministic red flag warnings, which we're still doing, of course, for March 6, 2017, but transitioning that more and more towards a probabilistic approach, which is consistent with the facets concepts coming out of the National Severe Storms Lab, where you're highlighting a specific area at greatest risk for significant fire, and then you're basically influencing the mobilization of supplemental resources to those areas. And in this example from March 6, 2017, we're able to influence the mobilization of upwards of 27 engines, 20 dozers, 2 air tankers, several Blackhawks, and then single-engine air tankers as well, an additional 43 support personnel to strategically important areas within that risk area where they could pre-deploy and have assets on hand in the event that significant fires do erupt. And on that day in particular, we did burn about 1.2 million acres across that high-risk area of the northern Texas Panhandle and northwest Oklahoma and southwest Kansas. But the real power in this, like I said, is when you can influence those strategic deployments of those resources and then tactically route those resources to newly detected fires. And that gives you, at least a chance on many of these days to suppress these fires early and help to evacuate folks in harm's way and help generally mitigate the negative adverse public impacts that you can have from these high-end fire events. And of course that relates both to rapid response of first responders on the ground, a management response to provide initial attack on these fires and hopefully mitigate them that way, but also an emergency management or a public response that may be needed downstream, downwind for evacuations in advance of the fires. So with that, that's pretty much the conclusion of what I want to discuss today on the notifications. Like I said, I'd be more than happy to take some questions about how we implemented this here in Norman, and Aaron is here also to cover any of the technical aspects of the application itself. Thank you.
Any questions for Todd? Todd, I'll just ask a quick question. Do you look to utilize the 1-minute data, get those mesoscale sectors on days of interest?
Oh, absolutely. Any day that we know that we're in for trouble with fires, we are requesting those mesoscale sectors, and we've used that very heavily.
Okay, any other questions?
Yeah, Todd, this is Dave from La Crosse.
Hey, Dave.
Hey, just wondering if you could share some of those color curves you're displaying there. Is that possible to share that on VLab, or?
I'm sure they are. I'm sure we could do that, absolutely. I know some of our forecasters have been a little inventive on their color curves, to try to pull out every bit of detail that they possibly can. And this might even be a good time to point out that some of our greatest success we've had this year has actually been with the fog difference channels. The 11 minus 3.9 difference channels seems to pick up on fire, little subtle hotspots even earlier than just the base 3.9.
Yeah, right. We noticed that here too. Just kind of wondering about the color curves. I suppose we could set those up, but if you have them handy, that'd be great.
Yeah, we'll try to collect several of the color curves and that we have innovated here, if you will, modified, and get those on the VLab page. I haven't thought to do that, so that's a good idea.
Great, thanks.
You bet.
Any more questions for Todd?
Hey Todd, Brian Mata. Wondering if you've considered using the framework for notification of other types of events.
Yes, we have. To my knowledge, we have not done that yet, but it was initially designed to be more versatile, I believe. I'll let Aaron kind of talk about that too. But yes, it definitely could be used for anything that you want to efficiently and quickly, send out information for a specific geolocation.
Yeah, it does have that capability. Some of the more recent versions have added things such as the templates that make the messages. You can kind of create your own custom ones. So if you want to do something for something other than fire, then you can do that. So yeah, it's been a work in progress to be able to kind of evolve that to be, more than fire, but it's definitely possible. Right now it does only do points, so it's really kind of point based. It's not, drawing polygons or anything like that. It's just kind of a point tool.
Okay, any more questions? Okay, at this point, we'll thank Todd for giving a great webinar, and if there's any more general GOES questions, we'll take those now. Okay, well, since there's no additional questions, we'll thank everybody, and especially thank Todd here for leading a great webinar. Thanks, everybody, and have a great day.